Related rates involve finding a rate at which a quantity changes by relating that quantity to other values whose rates of change are known. Here we're going to look at a problem about a juice-loving dragon named Dudley. Once there was a dragon named Dudley. Dudley the dragon loved drinking dragon fruit juice. One day, Dudley the dragon was drinking his dragon fruit juice when he noticed his cup had a hole in the bottom. If Dudley uses a conical cup with a height of 60 centimeters and with a radius of 10 centimeters, and Dudley's juice is emptying out of his cup at a rate of 5 centimeters cubed per second, what is the rate at which the height of juice left in the cup is changing when the height of juice left in the cup is 20 centimeters? First, we need to identify our knowns. So our knowns here are dV dt, which is negative 5 centimeters cubed per second, as well as the height and radius of our conical cup, which is 60 centimeters tall with a radius of 10 centimeters. We also know that we are solving for dH dt when the height is 20 centimeters. So it's always helpful to start with drawing a picture. So we're going to draw a picture of a cone. We're going to label the height, which is 60 centimeters, and the radius, which is 10 centimeters. We also need the equation for the volume of a cone, which is V equals 1/3 pi r squared times h. To start, we need to manipulate the volume equation so it has only one variable. In this case, we will be getting rid of radius. Here we use the rate r is to h as 10 is to 60. This is similar to relating similar right triangles in past math classes. For now, we cross-multiply to get r is equal to 1/6 times h. We plug this value back into the original volume equation for r. This new equation can be simplified to V is equal to 1/3 pi times 1/36 times height cubed. Once this is done, we can take the derivative of both sides of the equation. So that's d dt of volume, or V, and d dt of 1/3 pi times 1/36 h cubed. This gives us dV dt is equal to pi over 36 dH dt times h squared. Then we plug in our knowns. So dV dt we know to be negative 5 centimeters cubed per second, We set that equal to pi over 36. We still don't know dh dt, that's what we're trying to find. And we plug 20 in for the height because that's the height at which we're evaluating this equation for. From there we solve and simplify. So we'll get negative 5 is equal to 400 pi over 36 dh dt. Which simplifies down to dh dt is equal to negative 180 over 400 pi, which can be further simplified to negative 9 over 20 pi centimeters per second. And that is the rate at which the height of Dudley the Dragon's dragon fruit juice is changing when the height of the juice in the cup is 20 centimeters.